Okay, for 3-5, you're only going to have 5 questions for homework. Sorry, not 5. 1 through 8. Okay, just 1 through 8 for your homework tonight. That'll be due Monday. And we'll learn about Descartes' rule of signs on Monday. So we'll just do the first part, 1 through 8 of your homework. Okay, let's go ahead and go to 3-5, which is irrational zeros. So last time, topic 4, yesterday, we learned about rational zeros and used a theorem. Today we're going to do irrational zeros, which means they have like square roots or just decimals that don't terminate. That's what irrational means. Okay, so beginning 1 through 4, we're going to factor by grouping, and then we'll factor the rest, and we'll have some irrational answers. Then we'll have to use the rational zero theorem for the rest, okay? So, number 1, sorry, I misspoke there. You may have to factor by grouping. This one, we don't. This one is just X method. So find the numbers that times to 18 and add to -9. Okay, 18 and -9, 6 and 3, and we want a -9. So, -6, -3. Cool. So this will be, we want to find the zeros. So this will be x squared minus 6, x squared minus 3. And we're going to split each one of those up and solve it, okay? So x squared minus 6 equals 0. Now that I can't factor. That's why we're going to get irrational. I can't factor that farther. And then x squared minus 3, I can't factor that either. So we're going to have to solve. So x squared equals 6. X equals plus minus square root 6. That's 2 zeros. That's plus minus. Then the next one, x squared equals 3. X equals plus minus square root 3. Those are your 4 zeros, okay? Okay, let's do 2. So this one we have a slide and divide. So yeah, let's definitely do this one. So we want to find the zeros here. So when I slide the 4 back, I'll be factoring x to the 4th minus 33, x squared, plus 32. Okay, anytime your middle number is 1 away from the end number, it's the end number times 1, if you haven't noticed. So x squared minus 32 and x squared minus 1. Okay, then we slid the 4 back, so let's divide it. So this will factor 2. 0 equals x squared minus 8 times 4x squared minus 1. Okay, and actually I could factor this one more. You can factor the next one more, or you can just do it by solving like we did number 1. Either way, so I'll have 2 equations, x squared minus 8 equals 0, and 4x squared minus 1 equals 0. Okay, so x squared equals 8. X is going to equal plus minus 2 root 2. Okay, so let me pause there. If you square root both sides, 8 is 4 times 2, so that'll reduce to 2 root 2. Okay? Alright, next one. This will be 4x squared equals 1. X squared equals 1/4. So when I square root, I'm square rooting the top over square root the bottom. So x equals plus minus 1/2. Okay? And if you were asked to do the rational theorem, only this one would show up because 2 root 2 is irrational. If you were asked to do the rational theorem for number 1, you wouldn't get any of them. okay? Because they're both irrational. So, yeah, keep that in mind. All right? Number 3. Let's do that one. It's a factor by grouping. Cool. Okay? So, group them up, and we'll take the common factors out. So 0, we want to find the zeros, equals, looks like just x squared times 2x plus 5. And then the next set of terms is negative 12 is the GCF. 2x plus 5. Cool. So then we'll have 0 equals x squared minus 12 times 2x plus 5. Cool. That's ready to split up into 2 different equations. So, x squared minus 12, let's solve that. X squared equals 12. Then I'm going to square root both sides. So 12 is 4 times 3. So it'll be 2 root 3. Plus minus 2 root 3. Okay. And 2x plus 5, well, that's easy. X equals negative 5 halves. Okay. So these are our zeros. Okay. So that's nice because I could factor those polynomials. But 5 and 6 and so on, we can't factor by grouping or by the X method. So then we will have to use our rational zero theorem. And again, our rational zero theorem only tells us rationals. So in our possibilities, only this one would show up. 2 root 3 isn't going to show up. Okay? So this is when it gets really kind of crazy because you have so many possibilities. What I suggest you do is when you do this homework, which is only a few problems, maybe split up with a neighbor. Yeah, so I'll explain what to do with your neighbor to make it easier. Okay? So let's go back to the rational zero theorem. P is 36. Q is 1. So our possibilities of P over Q. Let's write out what P could be, the factors. So 1, 2, 3, 4, 6, 9, 12. Oh goodness. And 32. 36, sorry, 36. Okay, I think that's it. And then Q is just 1. Oh, nice. Cool. So obviously just 1. Our possible P over Q's are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 9, plus minus 12. Oh, I forgot one. Shoot. 18 times 3. My bad. So plus minus 18 and plus minus 36. Okay, so this is what I mean by a partner, which I would definitely do. Split them up. You could even do a group of 3, but don't get crazy. And someone can try 1 and then negative 1, 2 and then negative 2, 3 and then negative 3. Then your next partner could try 4 and negative 4, 6 and negative 6. 9 and negative 9. Okay, so split it up because when we find the remainder of 0, I don't want you to have to do all of these, okay? Help each other with that. So, let's find the 0, and then we'll have to factor it, and we should end up with your rationals. So kind of what we were doing last time. Alright, let's just go back over. Let me look at if I tried 1, what would happen? So my coefficients are 1, negative 2, negative 18, and 36. 3, 2, 1, 0. So I'm going to drop down the 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 18 minus 1 is negative 19. Negative 19 times 1, I'm not going to get a remainder of 0. So that's gone. You got to get a remainder of 0. Okay, so that's why I'm saying split it up with a partner. That's a lot of work. Alright, let's try 2. So 1, negative 2, negative 18, 36. Let's try that. So I'm going to bring down the 1. 1 times 2 is 2. Negative 2 plus 2 is 0. 0 times 2 is 0. Negative 18 plus 0 is negative 18. Negative 18 times 2 is negative 36. That gives me 0. Cool. So 2 is a 0. And then what's left is x squared minus 18. Because we have 0x. Okay, so now it's actually really similar to what we did a couple of sections before, but we're going to get irrational numbers left. So we're going to factor what's left. So x squared equals 18. Let's square both sides. 18 is 9 times 2. So that'll be x equals plus minus 3 root 2. And then we know x equals 2 from using the rational zero theorem. We plugged in 2 and got a remainder of 0. Oh, lots to say. Okay. Also, please don't forget that that was a 0. So don't just write what you find 3 root 2, like write the 0. Also, there's 3 of them. We have x to the third. Alright, let's do 6. And then I'll pick a harder one on the back. Alright, let's do 6 just to go back over what we're doing. Alright, through all of the steps, P is 60. Q is 1. Oh my goodness, 60. That has so many possibilities. Oh my gosh, okay. Alright, so 60 breaks into 1, and then Q is just over 1. So I'm going to go ahead and just write my P over Q's, okay? Because it's over 1, so it's just going to be whatever P is with a plus minus. So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, plus minus 7, 8, 9, no, plus minus 10, plus minus 12, 12 times 5, 4 times 15, so plus minus 15, 3 times 20, plus minus 20, and finally plus minus 60. Oh my goodness gracious. Oh, 30, plus minus 30, I forgot that too. Oh my gosh. Okay, so here's just a hint. Don't try these bigger numbers first, because they're not going to be a 0. If I plug in 60 here, I'm not going to get 0. I'm going to get a giant number. So definitely, like, try 1, 2, 3, 4, 5. Try those first, okay? 60 is clearly not going to give you 0 when you plug it in. So use that to help you too. Alright, since I've already done this, let's go to what I know will work, 4. And even though I say that, just still, you gotta synthetically divide anyway to find what's left so that you can factor it. Okay? So you've still gotta do that. Alright, so coefficients are 1, 1, negative 23. Woo! Jordy. That's my dog. Okay, negative 3 and 60. Okay, so we'll bring down the 1. 1 times 4 is 4. 1 plus 4 is 5. 5 times 4 is 20. Negative 23 plus 20 is negative 3. Negative 3 times 4 is negative 12. Negative 3 minus 12 is negative 15. Negative 15 times 4 is negative 60. Remainder 0. Woohoo! Oh my gosh. Okay, hopefully we can factor what's left, or this can be so long. Okay, this will be x to the third plus 5x squared minus 3x minus 15. Yay, we can factor that by grouping. Later on, we're going to get into polynomials that you can't factor again, so you have to do the rational zero theorem and pick one again. Pre-calc's got a lot going on. Okay, and you do use this in calculus, so don't think it's like for nothing. It is. Okay, now we gotta find those zeros. We're gonna factor by grouping because there's 4 terms. So that'll be x squared times x plus 5 minus 3 times x plus 5. So this will be x squared minus 3 times x plus 5. Alright. So x squared minus 3 equals 0. Means x will be plus minus square root of 3. And then x plus 5 equals 0 means x will be negative 5. And then we also found 4 from our synthetic division there. Okay. So if you were some lucky partner splitting all these up and someone tried negative 5 and you got a remainder of 0, that's cool. You just have a different function of factor at the end. Actually, I think that's kind of awesome. It doesn't matter what you do. You'll factor that leftover function and still get the same final answers. Okay? Let's just pick one hard one on the back. And that'll be it for this. We'll skip Descartes' rule of sign. Oh my gosh. Oh my gosh, these all take the quadratic formula. Okay. Alright. Let's go back over what that is. So on the side of your paper, you need to write the quadratic formula. Which is how we find irrational zeros that we cannot get just by factoring, okay? So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I can factor it this way. If I keep it up, I'm going to get an a. Alright, there you go. I should probably say what these mean. So, ax squared plus bx plus c. That's what this means. So, if your quadratic is in standard form, a will be the number in front of x squared, b will be the number in front of x, and c will be the last number. Okay? So, because of that, let's just go to 7, and that'll be enough. But just so you know, you might have to use a quadratic formula for some on your homework. All right. Let's write what P over Q is. And again, if Q is 1, which it is for most of these, it's really just going to be plus minus the factors of P. Okay? So P is negative 15, P is 15. The negative doesn't matter. So P over Q, since Q is 1, it's just going to be plus minus all the factors of 15. So plus minus 1, plus minus 3, plus minus 5, plus minus 15. Okay, and again, don't choose 15. You're not going to get 0 when you plug that in. That's way big number. Alright. Since I did these already, I know negative 3 works. So let's do that. Focus. Alright, coefficients are 1, negative 5, negative 29, negative 15. Let's bring down the 1. 1 times negative 3 is negative 3. Negative 5 minus 3 is negative 8. Negative 8 times negative 3 is 24. Negative 29 plus 24 is negative 5. Negative 5 times 3, negative 3 is 15, remainder 0. So what we have left is 1x squared minus 8x minus 5, and you right away should be saying, oh my gosh, I cannot x method this. There's no way I can get numbers that times to 5 and add to 8. That's why we've got to do the quadratic formula, okay? So a is 1, b is negative 8, c is negative 5. negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so this is to find the zeros once we factor x squared minus 8x minus 5. Okay, so x will be negative 8, which is 8, plus or minus negative 8 squared minus 4 times 1 times negative 5 all over 2a, 2 times 1. Okay? So x equals 8 plus minus square root of, I'm going to find what that is, 64 plus 20, so 84? Yeah. So this will be square root of 84 all over 2. 2 times 1 is 2. Oh gosh, and then we gotta break up 84. Alright, let me do that on the side. So divide by 2, and we'll get 42. Divide by 2, and we'll get 21, 7, 3. Okay, so 84 is gonna be only 2 repeats there, so it'll be 2 square roots of 21. Okay, so we'll have x equals 8 plus minus 2 square roots of 21 all over 2. And of course we're going to divide those out, so we'll have x equals 4 plus minus square root of 21. And we also know x equals negative 3 from our synthetic division. So those are 3 zeros. Alright. If you feel like you need a U-try, I'll rate number 8 the answer. 1, negative 3 plus minus 2 root 7. If you want to try that before moving on, you can. And then, sorry, these brackets are just me listing what they are. So x equals 1, x equals negative 3 plus minus 2 root 7. That's fine too. Okay? And all of these on the back you have to use a quadratic formula for. Alright, that's it.